So here I am, ayan3.MOD, and today my topic to you is stacks and queues. So it's a very important concept in computer science, and that you need to know this whether you want to be a master in any language or anything else. So it's a very basic concept I want to mention. So first I would go with the definition. So what are stacks and queues? So these are data structures, and it is used for storage, proper storage, and access of data from a computer memory. So you can understand the function of stacks and queues. So it's storage and access. Now, I would like to explain this more with an analogy, that how the human brain here calculates any topic, means any equation or something. Suppose I give you this equation. Can anyone come up with the result? 6. So it's really easy for us to calculate at this point. But suppose a small child is given this equation. So how does he calculate? He would first calculate this portion and would write 8. Or keep in mind 8. And then he would subtract 2 from 8 and give you the result 6. An even smaller child, he will calculate it 1, 2, 3, 4, 5, then add 1, 2, 3, and then reduce 2 from it. So that's how it calculates. To our surprise, we think that a computer can't do anything for us, but it calculates in the same way the smallest child calculated. So it adds up 5 with 3, like the way I counted, gives us 8, then 2 is reduced from it to give us the result 6. Now, what should have struck everyone, that there is a need of storing this intermediate result somewhere in our memory or the memory of the child, and then access that result and then reduce 2 from it to give me the final result. So now you can understand why we need storage for that intermediate value to get stored somewhere, and why do we need access to that value and reduce to get the final result. So I think I can I can explain to you somewhat the way stacks and queues may be used in different applications of computer science. So I think we are done with these two. Now, the thing is that I will go with analogy, description, and explanation together because they're so interrelated. So we call it LIFO for a stack, and FIFO for a queue. So, as you can see here, it's a stack of money. Here, it has only one opening to put all our value, means whatever we want to put into it. It's a sack-like kind of thing. So it has only one opening to put in. And if you want to take out some of our coins or some of our money, it has to go out through here. So there is only one point. So a stack can be considered like this, which has only one opening. This is a part of the computer memory, So suppose I am storing this as an intermediate result. So I will have to put 8 and it will go down. Now I put another intermediate result. So suppose it's 16, it goes down here. Now you can understand, if I have to access these two, first I have to take out 16, then only I can access 8 out here. So now there is LIFO, which stands for last in, first out. So the last in was 16, and it was the first thing to get out so that we can access 8. So this is what is called last in, first out. That's the concept behind stack. Now, if we consider a queue here, this is a concept of queue. So here you can find that it has two endings. It comes in from here, gets stored up here. Suppose it's the first one. Then the next thing comes, the first one shifts here, and this becomes the second one, and this becomes the first, and on this way. But here, we can access the first one from this end, because this is the entry, and this is the exit. Now you can make out why FIFO is. FIFO is first in and first out. Here the first one came in first, and when it's exiting, is the first one going out first. So this is FIFO. It's first in and first out. So here you can understand how a description means how this has been implemented in computer memory. Now the question comes is that what is the effective way of accessing each one of these elements in a computer memory? So there are something called pointers. What does this name suggest? Anyone? Come on. Anyone? It points to something. That's it. It points to a computer memory. So it's pointed. What does it point to? In case of a stack, what we need to point is that the top of the stack. The top of the stack. So it's called TOS. Is a pointer which points to the top of the stack. How does it help us in accessing? When we pull out 16 from here, first TOS was pointing to the 16. Now it would point to 8. So as soon as we pull out each values from a stack, the TOS goes down. The top of the stack has to point lower to get because the next time we access the stack, 8 will be the top of the stack, not the 16. But here, in a queue, we need 2 pointers because it has to point to 2 ends. So you can call it the top and bottom, or as I say, the entry or the exit. So it's up to you how you name it, but those are the pointers which are used to describe how a queue can be organized. Now, I will describe about all the applications of all these stacks and queues. I have given some applications that can be understood in such a short amount of time, but once I describe an entire program, you can understand it better, the application of the stacks and queues. We can take that up in later classes. As of now, I would go to the conclusion which shows that, to sum up, I should say, It's storage and access which matters, and the way you store, the way of access differs with it. The way you store it may be last in, first out, or the first in, first out, which gives you the storage and access way of stack and a queue. And this is how I end my lecture. Talk to you later. Oh, I'm sorry.